Muy buenos días, les invitamos a tomar sus lugares para iniciar de inmediato con este seminario en este viernes 4 de marzo. Bienvenidas, bienvenidos. Bien, pues muy buenos días. Nos da muchísimo gusto saludarles, darles la más cordial bienvenida a todas las personas que se conectaron muy puntualmente a este espacio de conocimiento en nombre del Mexicano de Tecnología del Agua, de la Cátedra UNESCO IMTA, el agua en la sociedad del conocimiento. Les damos la más cordial bienvenida. Como los viernes que compartimos siempre visiones interesantes, diferentes perspectivas de todas las personas que están trabajando en torno al agua desde diferentes visiones, de diferentes disciplinas, y hoy en particular iniciando un ciclo que encontramos de verdad muy interesante, muy importante. ¿Qué significa, qué implica hacer ciencia desde el gobierno? Entonces, desde este espacio vamos a estar compartiendo a lo largo del mes de marzo diferentes experiencias de reconocidos expertos como Hendrik Tolman, que nos acompaña esta mañana, de qué significa hacer esta ciencia desde las instituciones públicas, cómo funciona esta ciencia pública en acción desde diferentes instituciones, diferentes organizaciones vinculadas con el agua, que nos den muchas orientaciones y muchas referencias de cómo se trabaja de esta forma. De manera que esta mañana estaremos teniendo esta conversación, esta presentación del doctor Hendrik Tolman de la Oficina Nacional de Administración Oceánica y Atmosférica de los Estados Unidos, la reconocida NOAA, quien nos estará compartiendo su visión, su experiencia y dando algunos elementos importantes sobre hacer ciencia desde el gobierno. Yo quiero también darle la más cordial bienvenida a todas las personas que nos acompañan en las diferentes plataformas digitales esta mañana, tanto desde Zoom como en redes sociales del Instituto Mexicano de Tecnología del Agua. Nos puedes acompañar a través de Facebook, también a través de Twitter, también a través de Canal IMTA en YouTube, y estamos por la importancia de este foro y la relevancia grabándolo, de forma que si tú quieres volver a tener la información que se compartió aquí, pues va a estar disponible para ti en todas estas plataformas. Y si alguien conoces que no pudo verlo o presenciarlo en vivo de manera directa, bueno, pues ahí recomendarle que en estas plataformas que tenemos a la vista en la pantalla, pues puedes encontrar posteriormente en cualquier momento este material para que lo puedas analizar, compartir y poder disfrutar y poder aprovechar todo el contenido que esta mañana estaremos compartiendo con todas y todos ustedes. Como ustedes lo han visto ahora, los micrófonos de todos los asistentes se encuentran bloqueados y así van a permanecer a lo largo de toda la sesión, de forma que la interacción que establezcamos hacia el final de la charla del doctor Hendrik Tolman será por escrito. Les invitamos muy cordialmente a que por escrito, tanto en la sección de chat en Zoom como en la sección de comentarios en las redes sociales, en cualquier momento de la charla nos puedan hacer llegar sus preguntas, sus comentarios, y al final, en la sesión de preguntas y respuestas, pues poder abrir este diálogo con sus intervenciones y con nuestra moderadora de esta mañana. Yo quiero, sin más preámbulo, también darle la bienvenida a la doctora Iskra, que está por aquí ya, está con nosotros. Iskra, ¿cómo estás? Muy buenos días.
Hola, ¿qué tal, Marco, el equipo de comunicación y por supuesto a todos los asistentes y muy especialmente a nuestro ponente del día de hoy, el doctor Hendrik Tolman? Muchas gracias por la oportunidad de presentar esta charla tan interesante. Creo que viene una oportunidad muy grande que podríamos aprovechar para conversar acerca de la utilidad de la ciencia o la ciencia desde el gobierno, que es un punto de vista bastante interesante. Así que de nuevo les agradezco la oportunidad y seré entonces moderadora de esta sesión, presentando a nuestro ponente y posteriormente moderando la sesión de preguntas y respuestas.
Muchísimas gracias. Y yo tengo que comentarles y decirles que la doctora Iskra Mejía Estrada es la subcoordinadora de hidrometeorología en el Instituto Mexicano de Tecnología del Agua y dirige un grupo de investigación pues muy activo también y muy productivo. Entonces promete que esta charla será de lo más interesante y de lo más productiva para todas y todos ustedes. Y yo sin más preámbulo dejaría en el uso de la palabra a la doctora Iskra Mejía y que podamos iniciar esta charla a su vez con el doctor Hendrik Tolman, a quien saludamos con muchísimo gusto. Good morning, Hendrik. We're going to start.
Thank you very much, Marco. And again, welcome everyone. And thank you again to the communications team at the Mexican Institute of Water Technology. My name is Iskra Mejia Estrada. I am the head of the hydrometeorology department at this same institute. And I have the big pleasure to present to you today, today's speaker, who's a superb scientist. He's going to give us his outtake or his vision on science done from the government. Today's speaker is Dr. Hendrik Tolman, who is currently the Senior Advisor for Advanced Modeling Systems of the Office of Science and Technology Integration, the OSTI, of the National Weather Service in the United States. There he leads strategic planning for next generation of computer models and modeling approaches that are used for the NWS, the forecasting enterprise. He is also the originator of the WaveWatch 3 wind wave model. Just to mention how widely used this model is, the user manual and system documentation of the WaveWatch 3 TM version in its version 3.14 has more than 1,600 citations. He also has other research papers that have well over 100 citations each. Before joining the OSTI, he was at the Environmental Modeling Center, the EMC, again from the NWS, for more than 20 years as a wave modeler. He was also Marine Modeling Branch Chief and Director. Dr. Tolman holds a doctorate, a PhD degree, and engineering degree from the Civil Engineering Department of the Delft University of Technology in the Netherlands. He's a naturalized US citizen of Dutch origin. And without further ado, I would like to give space for Dr. Tolman to present to us his interesting topic and also his very interesting views on science done from the government. Dr. Tolman, please, the floor is yours.
There we go. So now you should hear me, hopefully.
Without problems.
Yeah, thank you about that. Sorry. First of all, thank you very much for inviting me to speak. I appreciate the opportunity. It's an honor for me to be able to speak here. Thank you for your introduction. Much appreciated also. I do want to make it clear, not because of all the things I've done, but because of the topic that we are using today, talking about how research and operations can be done within single organizations or between organizations. I would like to make the point that early in my career, I worked in the research environment, and even the first 10 years or so that I worked for NOAA, I was 100% working on research and development. And then from that, I slowly moved more and more into an operational environment. So by the time it was about 10 years into my career, the first WaveWatch model became operational at NOAA. And at that point, I really became much more in contact with the operational side. And as I moved forward, being a contractor, then a branch chief, then a director, and now a senior advisor for strategy, I have had the opportunity to work in all these aspects of science, technology, and operations. And so I was asked to talk a little bit about my experiences with science and operations, of course, against the backdrop of the organizational changes that are potentially to happen or are underway in Mexico. And so what I'm talking about is not necessarily how you should organize yourself, because you can figure that out probably better than we can, but talk about particularly my experiences on how we do scientific innovations, do research and development, and do operations, and how these things are linked, and what my experiences are with linking these things. And so I picked out 3 or 4 or 5 three or four topics that are very relevant for that. One is talking about the fact that the American National Science Foundation has been using the term valley of death for a long time when it comes to take research and bring it into operations. I want to talk a little bit about that. I want to talk a little bit about my experience with wave modeling, with the WaveWatch model, how that reaches from research to operations and how we are interacting between these at the moment. Then I'll talk a little bit about NOAA, about the National Weather Service, about how we have started to do business very differently the last 10 years and fit that into the broader NOAA organization. And then I want to talk a little bit about the Unified Forecast System, which is our modeling system that we're using now to link research and operations better, among other things. And then I hope to have about 15 or 20 minutes of time at the end to be able to have a discussion with the folks that are listening to answer more relevant questions for the issues that you in Mexico are looking at directly. So the National Research Council put out a report in 2000, and we reviewed that 5 years ago, 17 years in. And this is where this valley of death statement about going from research to operations, I think, originated. The original report in 2000 looked at two very specific topics. One was about satellites, and the other was about numerical weather prediction. And so it was really about, okay, how does NOAA, as National Center for Environmental Prediction, take research rapidly into operations? And so this is not a new problem. We've been looking at this for at least 25 years, and we've been calling this the Valley of Death for at least 25 years. And so 5 years ago, we did a review of this, of what we had done with this report. This was done as part of a program in NOAA that funds the transition of research to operations. And it was kind of disappointing in some ways because we implemented all the recommendations that we saw in the report from the National Academy of Sciences, but we saw very little impact on making the R2O process faster. It was kind of important to look at some of the things that had changed very significantly. One of the things in the report that is now 22 years old is that they criticized NOAA for the operations to try and do everything on their own. Well, 22 years ago, that was kind of a necessity. We in the Weather Service and in NSAP had the biggest computers in the world, literally. Our computers were in the top 10 of the Mannheim list at that time. We had a larger part of the young scientists coming into the Weather Service with meteorological degrees. And that is completely different right now. Now our computer is only barely in the top 200, and only 5% of students that come out of college with relevant meteorological degrees actually ended up working for us. So we had to be doing it on our own because we were the only ones that had resources. But now we're only a very small group compared to the really big community that works on this. So that has changed our needs and the way we're doing business. And so we are really looking at using this much broader community to help us with operations. Then we were working mostly with models that were built by the National Weather Service, particularly the weather models. That happened because we had to do the work ourselves to begin with. But for the last 10 or 15 years, we've switched over to mostly models that are built by a much broader community, like the WRF and the HWRF model, the HICOM Ocean model, the MOM6 model, and the WaveWatch 3 model. And very recently, just a few years ago, we switched over to a community model for the atmosphere too. So things definitely did change, and these things that were initiated by the report of the National Academy of Sciences actually helped us become more efficient in transition to operations. And there's also other reasons why this valley of death is not as big than was suggested 22 years ago. It is much about how much time does it take to make a new model operational. We need to make sure that the model always runs no matter what. And that means that we typically have to do a lot of hardening of the software. Nowadays, when we pick up new software, particularly from the community, This software is much more mature, so it takes less time to make it operational ready. And it also, what we can see in some of the software, community softwares that we have, they are more about having a framework with a lot of options in there. And so if you change the options in the framework in operations, then you don't have to reconsider the entire framework. So an example of that is that in 2000, the first implementation of WaveWatch 3 took about 5 to 7 years to get into operations. 9 years later, when we were having this whole framework in place already, we changed the grid from a normal structured grid to a triangular grid. We changed the numerics and we changed the physics in the model. So effectively, we put a whole new model in operations. And depending on where you start the clock, that only lasted 9 to 18 months to get that done. So with modern software, much more modern software and community software, we actually did succeed in getting the transition to operation significantly faster. And that has now become the unified forecast system, and that's something I'll have in my slides further down the line. So talk a little bit about my experience with WaveWatch 3, because I worked both in the science side and in the operational side for that model. Just the history of that. I started in 1985 working on that as my assigned doctoral project to develop that code. Then I spent two or 3 years with NASA as a postdoc with an opportunity to keep working more on it. And then I came into a very interesting situation in NOAA. NOAA hired me after my NASA postdoc to completely rebuild the wave modeling suite that they were running. And so I ended up having 100% of my time that I could use for research and development at an operational center. So I was in a very unique position. Almost nobody gets that kind of a position where they can work 100% of their time on research and development. Even in academia, that is usually not the case because you have to teach, you have to find money and all that kind of stuff. And the reason why we decided to build a brand new model and not go with the then existing community model was all about the software architecture of the community model that we didn't find was suitable for long-term use in research and operations and not efficient enough to be doing research and operations with at the same time. So we did not just build a wave model because I like to build wave models. We actually made a business decision for doing that. And I could have just as easily started working there on the community model than on my own model. And so it became a community model between 2000 and 2008. I documented the code just for my own sanity because I wanted to remember what I had done and not have to re-engineer many things. We already decided in 2000 to make this freeware, just make the community available to the code available to the community, Along that way, between 2000 and 2008, we did need to establish copyright and licenses because there were a few people who picked up the code and made believe that it was their code and all kinds of things like that. So we made one of the very first open source licenses that allowed basically everybody to work with the same code that we worked with in operations. We had to do that with a custom license because the licenses that were there 15 years ago were just not suitable for working with operational groups like the UK Met Office or with people in industry. And interestingly enough, it was not the licensing that was the problem for us to share the code, but the way the US at that time worked with export rules that have become a lot more lenient, but may become much less lenient with the international events that are occurring right now. The interesting part of that was that I just made the code available to the public originally as freeware, but because of the documentation and because of the fact that it was running in operations and therefore had a really good baseline published about what kind of work you could do with it, this became a tool for people in research and development as well as in operations. And this was not just the WaveWatch code. The same thing happened with the other big community code, which is the Swan code from Delft. And between those two modeling systems, the WaveWatch and Swan modeling system, we sort of changed the way how research and operations was done with the same tools. And by doing that, we also changed the way in which researchers are working together with people in operations. And so that was a rather important thing to happen about 15 years ago. And then since 2008, the WaveWatch code has been used for research and operations. In the introduction, it was already said that there are like 1,400 references just to version 3.14 alone, and that's one of the 6 versions of the code that have their own manual and references with it. And to give you an idea of how much of a difference this is, I already said about the fact that it took 5 to 7 years to get the first WaveWatch in. 4 or 5 years ago, we put in a completely new model in the Great Lakes. This was a unstructured grid model that was developed by a PhD student in Croatia for working with a university in Germany and a university in Taiwan. He decided that he didn't want to distribute his own model, so instead of that, he put this technology into WaveWatch. Then the French Navy and the Dutch Army supported him to make that more mature for operational work. And we literally, as NOAA, picked that up at no cost and then put it in operations in about 1.5 years. And so this is a completely different way for us to work with the research community, by us as operational people, providing the research community with tools to work with, and then the research community at their cost providing us with improvements that we were able to put into operations. So going to NOAA, to the National Weather Service particularly, a lot has changed in the National Weather Service over the last decade, since we had a big reorganization almost almost a decade ago. Before we had that reorganization, the National Weather Service was just putting out a forecast, which is basically what is done almost everywhere over the world. However, as early as 1993, Alan Murphy wrote a paper on what a good forecast would be. And he made the statement that the forecast by itself has no value, but the actual value of the forecast comes through the decisions that people make based on that forecast, or the exact quote from the paper is here in red. And so one of the things that we changed when we reorganized the National Weather Service is to not only think about running a model and providing a forecast, but looking at this process end to end. That meant that on the beginning of it, we spent a lot more attention on what our requirements and needs are. And on the backside of the process, we're not happy with just putting a forecast out, but we actually help people with making decisions, particularly people like the Federal Emergency Management Agency. If there's a landfalling hurricane, we have people from the Weather Service working with them, not only providing them forecasts, but making decisions on who should evacuate, when an evacuation should start, and all kinds of things like that. And it is not just the FEMA, but for instance, we usually have a few meteorologists working with big sport events and all these kind of things too. So after the reorganization, we were and we still are considering ourselves as a science-based organization, although we have a very much of a focus on operational work. That means that we want our operational solutions to be based on science and represent the best science that we have. The Weather Service has a focus on research, development, and transition, with a little bit more on the operational side. And we do not do generally fundamental research. And so requirements, development of requirements, development of solutions, and prioritization are done in 3 different parts of the organization. So we have a separate part of the organization that just gathers requirements. But a requirement is, for instance, my surface temperature needs to be accurate within 1 degree centigrade. But the requirements do not say you shall resolve that with this specific WRF model or whatever else. And so my part of the organization, what I work for right now, deals with the solution space. So after we get the requirements, we work to figure out what the best solutions are for running models for that. And then senior leadership of NOAA or the Weather Service then prioritize where we put our resources. With all these are being separated, we are working very differently than we used to work before, even within NOAA. If you want to know more about this, take a look at the link. We do have a governance document that describes how this works. And then the other parts that were very important when we started looking at doing requirements and solutions separately It allowed us to simplify the operational modeling we're doing. Historically, there would be an individual scientist that would put in a solution in the production for a simple problem. And that meant that in 2016, we had 26 different major modeling systems that we used, mostly because we had them put in by individual scientists. We've started simplifying that. We're now back to 21, and we're actually going towards 10 major systems, and I'll talk a little bit more about that in the UFS slides. It also changed the way we work together as teams. It's no longer the single scientist that runs the forecast system that makes the decisions that's in charge of the forecast system that makes the decisions for that. And we actually even have a group, which I think comes up in the next slide, that helps us work that way. So the bigger picture, NOAA actually consists of 6 line offices. Those are the 6 that are outlined here. Those are marine aviation operations. So the NOAA ships and the NOAA fleet are in those. It's our fishery services, which does what the name says, talks about and monitors fish catching and quota and things like that. And then you have the National Ocean Services, the Atmospheric and Oceanic Research, which is our research group, the National Weather Service, which I am, and the National Environmental Satellite Data and Information Services. So we work mostly with the Weather Service, directly with the Office of Atmospheric Research. So we should provide OAR with topics to work on. OAR should provide us with improvements that help for our weather forecasting. More and more, the 2 organizations in light blue are part of the bigger team. The satellite folks have usually just given us the data, but they are working more and more on products with us too. And ocean services become more and more of an important part of our problem because if we want to make sustained improvement on forecasting, we need to look at the environment as a whole, not just at the atmosphere, but the atmosphere, the ocean, ice, land, waves, and atmospheric composition all are important parts. And even fisheries and marine operations are slowly but surely becoming a part of that. Why is this important to understand? The way NOAA is organized, the authorities and the funding go to the line offices. So Ocean Service has their own responsibility and authority to do their mission. So do we, so does OAR. That means that NOAA does not have a tool to force OAR and Weather Service to work together and all of the other line offices. And so that makes it rather interesting from a organizational perspective, and that is something that you probably want to discuss with your changes in organization in Mexico too. And so the bigger picture, again, I've said that before a little bit. When we look at from the Weather Service perspective, we work mostly with OAR. So we are doing a little bit more mature research and development and the operations part. OAR works more on developing the research and or doing new research and development. And as NOAA, we have a problem that we don't do that much in fundamental research, but that's a little bit separate from that. So NESDIS provides us with data, but gives us more and more interaction with how we produce products together. And then fisheries and ocean services have their own mission. But like I said before, slowly but surely, these missions start to overlap more and more because the tools that we need and the science that we need are more holistic for the entire environment. I do want to make another observation here, the fact that NOAA, as a one agency, and the Navy in the US are having themselves organized significantly differently. So on the NOAA side, I've already mentioned the OAR and the Weather Service responsibilities for research. And then the transition is done by Weather Service with a little help of OAR. But we have something called NOAA NCEP Central Operations that does the day-to-day running. So the people who are doing our day-to-day running of our models are actually IT folks and not scientists. And so parts of the National Weather Service keep doing the the quality assurance for this. And so this means that particularly the Weather Service team is involved with pretty much all the research and all the operations at some level. If you look at the Navy, the Office of Naval Research is the focus for the research part. They go in 4 stages from innovation to getting things ready for operations. And then Fleet Numerical and Nav Oceano are the groups that are running the actual operations. And Fleet Numerical and Nav Oceano, as an operational group, do both the IT and have a scientific team to do the quality assessment. The thing that is different between Navy and NOAA is that basically the team that does the research at ONR, once the research is done, gets disbanded, and then it's handed over to another team at operations. And I could, if you're interested in that, in the Q&A session, we can talk a little bit more about what the pros and the cons of that are. I just want to point out here that we are definitely doing things differently in NOAA than we're doing in the Navy that way. So the bigger picture, weather service and OER collaboration is most important for us, and it has improved enormously the last 5 to 10 years. We've seen that if we advocate each other's work and if we work together earlier, that we achieve much more. So we are much more than the 2 individual organizations if we work together. And advocating, collaborating rather than working in stovepipes helps us to advocate for each other's missions. It leads to a much better R2O efficiency. And in general, this research to operation link is better for both of us, particularly for the image that we have with the people that fund us and the people that we work with. And so within NOAA, the thing that we're really missing is that we don't do the fundamental research innovation on the really beginning part of the research. And that means that we do need to work not just NOAA or weather service and OER together, but it's very important to have the broader research community with us too. And the one thing that is really important here, going back to what I said about how NOAA is organized, the authority is with the line officers. So the authority does not make us work together. It's the culture that we've built in the organizations that make us work together. And we do that because it benefits both of us in many ways, as just mentioned earlier on this slide. So the last topic I want to talk about a little bit about is this unified forecast system that we're developing. We've been developing that for the last few years. I started some of that development with the team when I was the EMC director, and I deliberately got into this job of being senior advisor so that I could spend all my time on developing this unified forecast system. And so this is sort of the unified forecast system idea as a whole in one slide. So we are working with a community-developed system, not with a NOAA-developed system, that is designed both as a research tool and as the basis for NOAA's operational forecasts. In terms of governance, this is all science evidence-based to be able to improve both to prove your research and to improve operations. The other thing that is important is it's one thing to have just a software stack that you call a model, but a model doesn't really mean anything till you make an application out of it, so you can measure how it works for that specific application. And so we are doing applications that are less than an hour forecast or nowcast all the way up to a forecast of a year. And we're looking at bringing in the decadal and centennial forecasting as part of the UFS too. Then the design is talking about a unified system where we share as much as we can between science components and in applications. The idea is that if you have individual scientists working on an individual process, you tend to get a lot of small projects, whereas if you have more people working on a single system, you have much more much easier critical mass to develop that system well. And then it's also important to say that we say unified. We don't say unitary. The goal is not to have just one model. The goal is to have the balance between focusing on a small number of solutions while allowing the diversity that you need for science and applications. And then for us, this is really a different way of doing business. And I find it really, really amazing to watch how the culture has shifted within NOAA to allow us to do this, particularly over a period of only about 5 years. And so is NOAA bought into this? Yeah, absolutely. NOAA started the Unified Modeling Committee about 6 years ago as part of the Science Council, which is a collaboration between all the line officers. I had the good fortune of being one of the founding chairs of that one. Last year, NOAA put up a NOAA modeling board where all the line officers coordinate their modeling work. 2 years ago, NOAA started a UFS R2O project where basically almost all the funding from OAR and all the funding from Weather Service for the UFS is coordinated in a large project rather than in individual science projects. Then about a year ago, we have the Earth Prediction Innovation Center, which is now required by law in the US and funded by law, coming into place. This prediction center is actually run by a contractor, not by the government at the moment, and is intended to accelerate the development of the UFS. And then we are working with a very broad community through the Unified Forecast System Steering Committee. And also NOAA makes some funding available for that through funding opportunities that are announced every year. And in the steering committee, I'm one of the two coaches. I'm the government co-chair of the steering committee. In the first 4 or 5 years, Ricky Root from University of Michigan was my co-chair. Just a few weeks ago, he retired from that job, and Neil Jacobs, our former NOAA administrator, is now working for UCAR as the full-time funded community representative for the steering committee. And so to let you show what we try to do with operations, from left to right is a timeline from where we are right now with 21 major forecast systems. And as you see, the color bars coalesce from left to right. This is tentatively where we hope to be around 2026. We hope to have reduced that to only 10 forecast systems. And we started a few years back with 26. So the state on the left already has 5 forecast systems being absorbed into more unified forecast systems. And so this is a massively different way of doing business for us internally, and helps the operations to be much more coordinated and much less fragmented. We're doing this with don't quote me on dates here, because this is notionally planned for an annual funding cycle. What is really important here too is that we are working with the broader community. We actually recognized that between Weather Service and NCAR, we have the same need for the infrastructure for these coupled modeling systems generally. We acknowledge that our infrastructure is already based on a lot of work done by NASA, NOAA, the Navy, NSF, DOE, and others, and that we were already working on a lot of software packages together anyhow. So we formalized this memorandum of agreement between NCAR, which represents order of 100 universities that work on atmospheric problems, and Weather Service and OAR in 2019. And we actually managed to identify 7 different areas of collaboration. And without going into too much detail, the first 2 on the coupling side, the academic community really wanted to use our operational coupling techniques because they considered that to be the best in the world at that time. We have been working with the community, having them more of a lead on our workflows and our hierarchical development capabilities. And there are a few other things here that are mixes of places where operations and the government and academia recognized that they could leverage each other's work enormously. And so if you look at this list of things and the things we're using, the Unified Forecast System, the UFS, is actually becoming more and more like the Community Earth System Model, the CESM from NCAR. And the biggest difference between those two is that NCAR tends to focus on decadal and centennial problems, where we focus on everything less than a year. But the point here is that we have a formal agreement between different organizations that help us to work very close together between research and academia. And Although they are not involved in this, we're seeing more and more small businesses that are commercial, private industry businesses working very close with us too. So my takeaways from this, before we can spend a little bit of time on talking now, it's fairly simple. No matter what you do, culture eats planning every day. This is a quote, I think, from somebody from IBM. If I had the quote available, I would properly recognize that. And so it doesn't really matter how you're organized in groups, or whether you're working together or not, or whether you're having different authorities, as I can see that even within NOAA, where we are officially one organization, but the authority tells us that we are 6 different groups. The culture is the driving force for the success of working together. It's much more so than the planning. And with that, the Weather Service actually recognized that culture and organizational prowess is something that is so important that we actually put up a Office of Organizational Excellence specifically for that. My view also that is when I started my career, because of who had resources, it made sense for me to work by myself. Now that is completely not true anymore. It is important to work in holistic teams and in unified approaches over smaller stovepipe. It helps the efficiency for everybody who works, no matter what. It reduces the number of duplication of work, and therefore the amount of money that is wasted because you pay twice for something. One of the things that makes it very hard for research and operations to work together if the researchers just hand off stuff at one point to operations, which means that operations often has to redo a lot of work before it can put things in. It is much more important to have this continuous handshake all the time. So if our research organizations are working on something that they're planning to go into operations, they start working with and discussing with operations from the start. And there's not one single handoff point. Our operational people are starting to play with this new stuff way before it's completely ready. And what is really important, the number one argument that I hear against a unified approach from scientists is that scientists say, but this just suppresses diversity. Having worked on both sides, and I mean diversity of scientific options here, since we're talking about diversity in other contexts a lot too these days. It is my personal experience that if you do modern software design, where you are designing a modeling structure and a modeling framework rather than just one single model, and if you do that in a unified approach, is that you have all the diversity that you need for most development work. And even in NOAA, we are not making the unified forecast system a mandated thing to work with. If you have a science idea where you can make the case that you have to work outside of that framework, we will listen and we will pick that up if it's necessary. And one of the most important parts of working holistically together in the culture is that you tend to become advocates for each other's work. And I don't know how that works in Mexico, but I've seen it in the US quite a bit, is that the more OER and Weather Service work together, the more positive attention we get from our people that provide us with resources. And so it leaves us not quite 15 minutes, but about 10 minutes or so at least. And I have a little bit more time behind that if we want to do some Q&A, because I've been talking about my experiences with having research and operations work together, but you have a much more specific question you want to ask on your side. So I will stop sharing my screen and I'll give it over to, I think it was Iskra. Are you going to run the discussion?
Yes, I will, Dr. Tolman. Just before we start, would you mind sharing again your screen so that the subtitles are still working while we hold the discussion, please?
Sure.
Thank you very much. Oh, brilliant. Right. I have a couple of questions that were posted in the Zoom chat. I'm going to start with them and then probably move towards maybe other platforms if there are any other questions in maybe Facebook or any other social media platform, just Marco, please let me know. The questions we have are from Agustin Breña. He is the head of the hydrology department here at IMTA, and he has two very specific questions that I think are quite interesting given everything that you have explained to us. His first question is, how much does NOAA collaborate with external partners such as universities, states, and private companies?
So it depends. Well, first of all, Agustin, thank you for inviting me, because you're the reason why I'm here to talk in the first place, and I want to acknowledge that. It depends a little bit on where we are locally, and it depends a little bit on what you're talking about in terms of the part of our mission. So, for instance, on our mission, end-to-end mission of providing service to the public, for instance, our Alaskan region is working incredibly closely with indigenous people. It works with the local universities, and it works with Homeland Security. And so Alaska is really an example of how to work together on the service provision part. And I want to particularly point out that, and I use the right terminology here, that they work a lot with the Alaskan Native population. And if you go back to my focus of the work, which is more on the modeling part of it, I pointed out in my slides that OAR and Weather Service are working much closer together, which is a good thing. But you were asking specifically about the broader community. So NOAA by law has some of its funding that goes out to funding opportunities for people from outside of NOAA. So between Weather Service and OAR, I don't know the exact number, but it's of the order of $10 million a year that we have available to fund external collaborators. That is done through a competitive system normally. And it used to be somewhat difficult to do that, in the sense that the questions that we could ask our collaborators were such that typically only 1 in 3 of the projects that we funded were easy to bring back to NOAA because of the fact that we didn't have that good linkage between the research community and what we're doing in NOAA. Over the last 5 years, with a focus to ask people to work with components of the UFS and ask people to work with specific community models, we switched that over to being able to use, at least in principle, have almost 100% of these projects that we fund have an identified place where they're going to help us in operations. So we're working a little closer with the community through these funding opportunities. And with the changeover from having internal models to models that can be used by anybody everywhere, plus the fact that all these models are freely available on GitHub right now, as well as applications, we are seeing a big acceleration into the academic world wanting to work with us. For example, the American Meteorological Society annual meeting in January, there were about 80 papers, research papers, presented on the Unified Forecast System, and less than a quarter of those were NOAA, were people from NOAA operations doing that. So we see that thanks to this joint technology that we're using, thanks to our commitment to community modeling, and thanks to a clear message about which things can go into operations quickly, and thanks to the fact that people in the research community with the operational models that they can now implement in a matter of days instead of in years, and have a very quick way to go to research. We see a culture developing where research and operations work way closer together, and we see this accelerate very rapidly at the moment. Does that answer your question, Agustin? Did I miss that part of it?
I'm pretty sure it did. It was a really, really nice explanation on this. And it was really interesting that you mentioned 2 key points. The first of all are these funding opportunities. So I believe that this opens opportunities, opens wide doors to collaborate with other institutes, other universities, companies. So I think this is an example that we might consider taking to expand or to broaden the collaboration of IMTA, for example?
Yeah, I think it's very powerful that we can do that. But I don't want to take all the credit for that, because this is basically we are told to do this by law. When we get our annual funding, we have some of our funding is designated for these kind of funding opportunities, and the appropriations law specifically says that we cannot spend that money on ourselves. We have to spend that money on external collaborators. And so it becomes really interesting, because usually these external collaborators, in order to have a chance to get funding, want to have people to work with within NOAA, but these people within NOAA then do that as part of their existing job. They don't get separately paid for that. So it's an interesting way that we are forced to do this way. But we really like it too, because it helps us, and it forces us to have this discussion with a much broader group, and to be able to have this discussion with the broader community, as well as the direct help from an input from the direct community too. And one of the things that I didn't mention is that just by doing this, the biggest problem with operational model is that you never have enough people to look at your results and to find all the problems that you have. And just by doing this, we have so many more people looking in detail at our forecast every day, that we have much more feedback when something goes wrong. And hopefully that will translate in us getting much quicker, better in the future too.
And just a quick follow-up question before I move on to other questions I posted in the chat and on Facebook. Do you have an estimate on how much this funding is, or what percentage of the total budget for NOAA that's dedicated to?
This is a very small part of our budget. The weather service budget is order of $1 billion a year, but more than half of that goes to our forecasting, the salaries of our forecasters, and it's only of the order of 5 to 10 million that goes out. So as part of the budget, this is a very small part, and I want to make sure that I'm making it clear that I don't know the exact numbers here, so I may be off by a little.
Very much, Dr. Tolman. I'm going to move on to a question in the Zoom chat, and then I'll come back to Agustin's second question, so that we also have participation from other attendees. Roberto Ramirez, who belongs he is a researcher here at the Hydrometeorology Department at IMTA. He wrote, "We are currently using results from numerical models that are generated by NSIP for the generation, evaluation, and correction of weather forecasts at local level. We would like to establish a line of communication to formally think and be able to use information that you kindly share with us and the scientific community." So this would be a question to establish these links or the connections, because like Roberto mentioned, we do a lot of research here. And a really key point, an interesting point here is that the operational side of weather forecasting is not done at IMTA, it's done at another institution. Would you mind commenting on what Roberto just wrote, please?
Yeah, I think I've got the question right. Hopefully. So first of all, if you want to know more about how we assess our systems, there is something called a model evaluation group, MEG, which meets technically every week, I believe. This group discusses forecast problems and issues that we have with our systems. It also, when we go to a new version of an operational system, this group does presentations on assessments of the quality of the new system and the differences. These meetings are generally open. I can provide the link to that offline later if you want to. That's basically our open system. It doesn't matter where you come from. If you want to do a somewhat more formal interaction, then that is something that would have to be done through our International Affairs office.
Thank you very much, Dr. Tolman. We have another question on Facebook. Pablo Martinez asks how we can get involved young researchers in works done by the government.
That's a good question, and that is from my perspective, the biggest problem we have in our field is the fact that we are not doing a very good job in branding ourselves and showing the good work we're doing. And we're not doing a very good job in interesting young folks to come into our organization. So I have the opposite problem from the question that was asked. I have a hard time finding qualified people that are young and early career. And so that's point number one. And point number two is this is the whole idea behind the unified forecast system also. Making that a tool to be able to work with the same tools that we use in operation as something that you can start your career with, either as a tool in a digital laboratory when you go to school, or when you have to do projects for either undergraduate or graduate level. If you start working with these kind of tools already, and with some of these applications that we have, particularly for global environmental modeling, or for medium range local modeling, or for hurricane modeling, show the work you're doing at the conferences, and I can guarantee you that even if you haven't shown anything on the conferences yet, that if you share your work with people in the government, that you will get interest from that, and that's the first step to get your foot in the door. Any student who wants to do anything like that, it's one of my jobs to do outreach. Just drop me a line, and I can see if I can get you in contact with the right people. And we hope that over the next few years, as we get closer and closer with the unified forecast system, to be able to give you a copy of, for instance, our hurricane model, where you as a student would be able to start research literally in a few days, because it will take that little time to get that model installed. Then I hope that we'll make it much easier for you as a student to start working much earlier with people in NOAA, and whether it's research or whether it's operations. And this goes back to what I said a little earlier too. I mean, it's all about starting to talk the same way I need to talk early to my people in research in the government. The earlier I talk to people in academia, the better. The earlier I know which students are coming down the line, the easier I'm going to have a time to actually hire the right people, because we are, at least in the US, the government is a very aged community. When I became EMC director, I was 53, and I was in the youngest 50% of the federal employees. And even now, I see a lot of people of my generation retiring, but we, at least in the US, have a problem with the fact that we need to get a lot good qualified young people in our system. And so I see it's a daunting task when you're a student trying to plan out your career. But talk to us on conferences. If you work with things like the UFS and the modeling side, share that with us, and you'll find that building those networks early on will help you with your career like nothing else. It will help us too.
I completely agree with that. The younger that people start getting involved with science, and to reach out also to organizations like NOAA, the better opportunities they have to start building a career in science. So this is a very good advice for all our young folks listening.
Well, for me, it's double up, because one of my children just graduated as a software engineer, and it's really fun to see how he is finding his way into a career.
Amazing! Congratulations on that. That's really great. So I'm coming back to Agustin's second question, and then we'll move on to other questions. Agustin asks, what are the main differences between doing research within a university or research center and the big governmental institutions such as NOAA. I believe you talked a bit about this difference, but if you could address Agustin's questions, I would be very grateful.
It really depends on where you are in the government, and it also depends on where you are in a university. I was, like I said in my second slide, I was very fortunate, extremely fortunate, that I ended up in a research position where I literally could spend 100% of my time on research. That is not normal. If you go as a PhD student or an undergraduate student work with the university, you come pretty close to that, except for the fact that you will need a lot of time on education still. And so if you're a PhD student, you're still not 100% of your time on research. You're still learning a lot. If you're a professor, you spend a lot of time on finding money for your students and for yourself. The higher up in the organization you get, the less research you're doing, because you have all that other stuff around you. In many ways, the government is not that different. The difference between government and academia for me is mostly that most of the government, at least if I look at the US, everything except for the National Science Foundation is mission driven. That means the research you're doing in a mission driven organization has to have a target for helping your mission. So it tends to be that if you do applied research and research and development and transition of research, that is where the focal points of most of the government agencies are. The only part that is different in the US is the National Science Foundation, that by definition is focused on fundamental research. And so if you go to academia, it really depends on your professor. It really depends on your on the group that you're working for, on the dean of your university, where the focus points are. And to give you just examples, I'm not advocating one university over another. For instance, the University of Rhode Island, with some of the professors there, particularly Isaac Guinness and Tetsu Hara, have always had a focus on doing operational hurricane modeling. So that specific academic group had a very, very close link with the government part, and would basically operate almost like a government lab. If you look at other places where you do really fundamental research, that will be very, very different. So if you have a group in a university that focuses on that, it will be different type of work. But I think the point I'm trying to make is that there is no one-size-fits-all answer to that, and that there's a lot of overlap in the type of work you're doing in a government lab or in a university lab. But for me, from the NOAA perspective, the only real difference is that NOAA doesn't do very much real fundamental research. So if you're interested in that, you're better off in a university. And the sales point I'm trying to make here is that we need each other. We need to work together. And that if we work together and establish these relationships and establish that culture, it doesn't matter which organization you're in, because with the culture of collaboration, both of you will benefit, no matter where you are in the government or in the academia.
That's a really good point. That pure research is done mostly in universities or pure research centers. And following that idea, precisely, there's another question that I'd like to ask you about this integration of the science and operational side, and also the integration of the different groups at NOAA. I agree that this is an approach that works well for everyone, because like you mentioned, all the forecasts and all the results, the outputs of the simulations are not only to give information or to give maps, they also inseed in the decisions that are taken by end users. And they contribute to making decisions. So I would like to ask on this, what were the main challenges that you found when trying to integrate all the groups, or trying to integrate these two very different approaches, the pure science and the operational side? Because it sounds like it might take a while to integrate both groups and both approaches. And if this is a path that we might follow at some point, it's important to know what were the main challenges or the main difficulties that you and the team at NOAA found during this process?
Well, again, it's my personal opinion here, and there's only three answers to that. It's culture, culture, and culture. If you don't have a group of people that see the benefit of having research and operations work together on a cultural level, then it is very hard to efficiently work together. What I've seen in NOAA more than anything else is that culture change made the change in us being more efficient. 10 years ago, OAR, so the research part of NOAA, and weather service part of NOAA were not working together very well. Weather service was not really telling research what they needed help with. Research tended to be very much, we can tell you what's better, just take it. And that was a cultural situation that the research community has a landing spot for the work they're doing, and so that makes it such that it is a little bit more worthwhile what to do. And for both of us, we are able to get our work done faster because we're working together and we leverage what we're doing, which is beneficial for our reputations, for our output, and for the way we are seen by the government that pays for us. So for us particularly, it was breaking down that culture barrier first is one of the hardest things to do, but it's also what I think gave us the best benefit here. And again, this is my personal opinion. I'm not giving you an official NOAA answer for that one. I just want to make sure that is the case. And having said all this, we're living in a very changing world, and that is also a cultural problem. I've said that before. We had the problem that we had to do everything ourselves 25 years ago when I started because we were the only one with resources. Nowadays, making established researchers understand that things like open source and community modeling can be a benefit and is not just a threat for your intellectual property and things like that. That's a cultural issue you need to deal with. The fact that my generation of scientists tended to have to work alone and learn to work alone, and now our problems are so complicated that you have to work as a team. So you have to have a different skill set, which is making it hard to get this culture change in place also. And then on top of that, for us, the fact that the way we're doing business changed in 3 different ways. I did a TED talk on that in Georgetown about 1.5 years ago. We're having the modeling the UFS is a change of doing business. Different fields like artificial intelligence and using that means we have to have different people. And the fact that social and behavioral science is something that we have to do right next to all our physical sciences in order to be efficient teams and in order to do this decision support at the last part makes it very interesting. But the point is, if you do not get the culture in place that the organizations want to work together, then it becomes very hard to make the collaboration efficient. If you can get this culture in place, then very often people will realize that 2 organizations are more than the sums of the part. You can leverage each other's work. You can effectively advocate for each other's mission and resources, and you tend to get a much stronger position in the community as a whole. I hope that helps a little.
That's a huge takeaway message. Definitely, that the culture of the workplace is really important. Is definitely crucial to provide results in a timely manner. And regarding this, what you just mentioned, when this new culture was implemented at NOAA, was it a bottom-top approach, or was it an up from down approach? Who contributed first to this change?
A bit of both.
That makes sense.
I would say that again, this is my observation, and in some senses, even very early on when I worked with the WaveWatch model, we had informal relationship with the Corps of Engineers with the Navy, that completely informal, almost at the worker level, that NOAA would concentrate on waves, that the Navy would concentrate on the three-dimensional ocean modeling, and that the Corps of Engineers would focus on depth-integrated storm surge modeling on the coast, and that we would share the software between each other. That was that came from the workforce, that was acknowledged by leadership. So that was a very clear starting point, bottom up. But then our director of the Weather Service, Louis Cellini, just retired in January 1st. Craig McLean, the director of research, is about to retire in April. But the two of them became really, really strong advocates of having to work together. And so that means that we also had a very strong top-down approach with that at the same time. So it's basically, we have both, there's no doubt about that. From my vision, from my perspective, the workforce level was more of the bottom-up, was more showing the potential that you could do it. And then the top down was, this is something that we really, really want to do and try everywhere. And this is, again, I mean, I want to make the point in general, from the quote I had, that culture eats planning every day. And culture change is something that is very different than organizational change by itself. It's a very different challenge.
It is. It's a whole challenge in itself. I agree. Indeed. Thank you very much for your answers. We'll have to cut the discussion here, but before that, I would like to thank you for all your deep insights on what it means to work, or what's the work culture at NOAA. I think there are lots of messages and loads of key points that we are definitely going to keep. Loads of takeaway messages as well, and we really appreciate your participation here, your availability to give such an interesting talk and to give us your opinion and your intake on loads of points that we've discussed today. So again, thank you very much, Dr. Hendrik Tolman, researcher at NOAA. And with this, we are closing your intervention, and then I'll give the mic to Marco, please.
Muchas gracias, Iskra, y también muchísimas gracias al doctor Hendrik Tolman por su charla, por compartirnos esta visión, esa experiencia sobre pues todo lo que ya nos ha comentado. Muchísimas gracias. Estamos llegando al final de nuestro espacio de conocimiento, que de verdad ha sido muy interesante poder contrastar, ver, profundizar un poco en este vistazo que nos proporcionó sobre el quehacer muy diverso y muy amplio de la NOAA y cómo se amalgaman estas actividades o estas funciones operativas con las funciones de investigación, y cómo el trabajo en equipo pues es uno de los caminos, pues el camino a seguir. Muchísimas gracias, Hendrik. It was nice having you in this show. Lo que queremos hacer ahora es tomar una imagen, una fotografía del grupo, como hacemos ya una tradición en estos espacios. Queremos tomar una imagen. Lo explico porque Hendrik conoce también y habla un poco de español, entonces también estoy obligando un poquito a que practique su español, y en lo que encendemos todas nuestras cámaras para poder tomar esta fotografía y esta imagen del grupo, yo quiero aprovechar también para hacerles algunas invitaciones a próximos eventos que estaremos compartiendo. Muchas gracias por ayudarme a compartir la pantalla. Si vemos la siguiente, por favor. La próxima semana, el 11 de marzo, a las 10 de la mañana, en el horario tradicional que tenemos en este espacio de conocimiento, tendremos en esta visión de las experiencias de hacer ciencia desde gobierno a George Heim. Él está en la oficina suiza del medio ambiente y nos estará compartiendo también estas visiones desde su particular intervención y desde el quehacer específico de esta oficina, de esta agencia del medio ambiente en Suiza. El registro está ya abierto en los sitios y en las plataformas digitales del Instituto Mexicano de Tecnología del Agua. De verdad, igual de interesante que la charla que tenemos hoy, no te la pierdas para poder completarnos esta visión amplia, diversa de los mejores investigadores y de las mejores experiencias en el mundo en torno a hacer ciencia desde el gobierno. La que sigue, por favor. Y tenemos convocatorias y tenemos invitaciones para ustedes de varios cursos. Uno que está ya próximo a realizarse la próxima semana, Hidrología de Superficie. Están la convocatoria en los correos y en la página que tenemos en la pantalla. Si estás interesado en participar, todavía hay tiempo de que puedas conectarte para tomar parte de este curso que tendrá una duración de 15 horas. Y si te pierdes esta información que estaba presentando aquí en vivo, lo puedes ver en la grabación o puedes acceder a las plataformas del Instituto Mexicano de Tecnología del Agua para que puedas tener toda la información que necesitas si quieres participar en este curso. La que sigue, por favor. Modelación de escurrimientos de cuencas con HMS. Otro curso, lo tendremos del 14 al 18 de marzo, también en materia de hidrología, con el maestro Juan Francisco Gómez. Toda la información y los detalles en imta.edu.mx y también en el correo electrónico que tenemos en pantalla. La que sigue, por favor. Ley de Aguas Nacionales, aspectos relevantes e institucionales. Importante tener a la vista las implicaciones legales que tienen que ver con el manejo del agua. Este curso del 28 de marzo al 1 de abril en la misma plataforma de actividades educativas del Instituto Mexicano de Tecnología del Agua. Tienes toda la información si los aspectos legales están en tu campo de interés profesional o académico. La que sigue, por favor. Tenemos también para nuestros posgrados en el Instituto Mexicano de Tecnología del Agua la convocatoria a la maestría en Ciencias y Tecnología del Agua en tiempo completo, modalidad presencial. Son 4 semestres. El calendario ya está publicado también y aquí lo más importante también es poder acercarte al sitio de posgrado para que puedas tener toda la información si estás interesada o interesado o si sabes de alguien que esté interesado en cursar esta maestría, pues poderle compartir esta información. La que sigue, por favor. También tenemos la maestría en Gestión Integrada de Recursos Hídricos. Esta es una maestría a distancia, recomendable como una maestría también profesionalizante para quienes ya están en alguna actividad profesional y que tienen tiempo parcial, digamos, para poder completar su formación académica a nivel de maestría. Pues esta es una muy buena oportunidad. Gestión Integrada de Recursos Hídricos, esta maestría que ofrece el Instituto Mexicano de Tecnología del Agua. El calendario ya también está publicado y pues las fechas clave presentes para que no se nos pase el tiempo y podamos cumplir con los requisitos si estamos interesados en participar. La que sigue, por favor. Y bueno, recordarles que tenemos diferentes sitios y espacios para difundir conocimiento, para divulgar también conocimiento en este boletín quincenal que tenemos desde el Instituto Mexicano de Tecnología del Agua, Hidrófilos, pues una reseña de la vida, una semblanza del doctor Enzo Levi, un hidráulico pues connotado y muy notable que nuestro país dejó grandes enseñanzas y también pues dejó una importante producción también intelectual y académica y pues un amplio reconocimiento de todos y que incluso en algún momento fue colaborador de este instituto hace ya algunos años. Que en paz descanse, pero queremos compartir con ustedes esta semblanza y mucha más información. La que sigue, por favor. Y bueno, les invitamos, por supuesto, a que nos visiten a la página institucional del IMTA, donde tenemos mucha información, pero en particular en esta columna de perspectivas, donde proporcionamos o donde ponemos a discusión algunos temas fundamentales para la agenda del agua en México y en el mundo, el papel de la tecnología y la innovación en el desarrollo equitativo de nuestro país. Una interesantísima aproximación que les invitamos a conocer y que semana con semana pues nos sigan acompañando, leyendo, discutiendo y proponiéndonos además nuevos temas para estas perspectivas que esperamos que aporten para la discusión de los temas fundamentales del agua en nuestro país. Creo que esta es la última. Y regresamos a la de las redes sociales del instituto y ahí nos encontrarán para próximas convocatorias y toda la información que se genere, pues ahí la estaremos compartiendo con muchísimo gusto con todas y con todos ustedes. Creo que esta es la última y regresamos entonces ya a la pantalla de pantallas para que todos los que estamos aquí presentes podamos encender nuestras cámaras y poder tomar entonces esta imagen del grupo. Yo quiero también comentar y aprovechar que si ustedes son observadores, nuestro invitado de esta mañana, el doctor Hendrik Tolman, es además un dato muy interesante, aficionado a la construcción de botes como el que él estaba utilizando en el fondo de su pantalla. Ojalá que algún momento tengamos oportunidad de escucharte y de conocer más de esta afición, bueno, más que una afición, un profesional, él y su familia, en la construcción y en los aspectos de navegación y de todo esto que además también pues son actividades muy, muy, muy interesantes y que pues seguramente hay muchas personas que estamos interesados en conocer un poquito más e invitarte también hay muchos cuerpos de agua en México donde podemos poner a prueba también pues toda tus construcciones y tu obra como la que nos estás mostrando en este momento. Entonces, si están de acuerdo y es el momento adecuado, ¿qué les parece si a la cuenta de 3 nos regalamos una gran sonrisa por haber formado parte de la comunidad que compartimos, que coincidimos esta mañana en el espacio de conocimiento con Hendrik Tolman, con la doctora Iskra Mejía? Muchísimas gracias, Iskra, por tu brillante trabajo de moderación y a todas y todos ustedes, por supuesto, por su compañía y por su atención. No nos queda más que pues desearles un feliz fin de semana, un feliz semana de conocimiento, una feliz inicio de la próxima semana también y que todas sus actividades florezcan y prosperen como ustedes lo desean. Entonces, a la cuenta de 3, pues nos regalamos una gran sonrisa para poder tener esta imagen de conjunto. 1, 2 y 3. Y tal vez saludamos a la cámara, mandamos saludos y los mejores deseos para todas y para todos ustedes. Muchísimas gracias, Hendrik. Un placer y un gusto conocerte y tenerte con nosotros. Muchas gracias y nos estamos entonces viendo y escuchando en el siguiente espacio de conocimiento. Hasta pronto. Muchas gracias.